Okay, get excited. This is going to be like the easiest lesson we have done since I've been back. 6.1, adding and subtracting polynomials. So there's a few different things that we need to take note of before we get started. First of all, I'm just going to highlight some things, and you should probably pause and take a second to write them down. Okay, so first of all, standard form of a polynomial is just in decreasing order. So the example that they have written there doesn't make any sense, but you may just want to write standard form is decreasing order of exponents. So the exponents need to decrease when you write something. So that would be, for example, like, I don't know, p of x equals 3x to the 7th minus 2x to the 6th plus 8x to the 5th minus 4x to the 4th. Right, just pay attention to the fact that these exponents are decreasing each time. The other things that we need to take a note of, a polynomial in general is just something that has many terms, right? Poly means many, and terms, each one of these little pieces is called a term. So terms are separated by addition or subtraction. So these are each terms. And a monomial is when you only have one term. It doesn't mean that you only have one variable. It just means you only have one piece. I kind of think about the monomials as pieces. So if we look here, if we start identifying, this will probably be the easiest way to make sense of all of that vocabulary. So identifying monomials, they've given us a whole list of things here. Which ones are the monomials? And I'm just going to circle, like x to the third, that's a monomial. All of this right here, a squared b, c to the 12th, that's a monomial. See, it's all squished together like one piece. The other ones that they've given me here that are not monomials, so my things that are not monomials, this whole thing, that's not a monomial. That right there has 4 terms in it. 76 is also not a monomial. 76 is a constant. That a constant is just any number that's hanging out by itself. So if we talk about the degree of each monomial, and they're going to lie, they're going to say that that is a constant, is a monomial. We'll talk about that. The degree has to do with the total number of exponents. So x to the third, the degree is 3. On this other one, I've got 2 a's, a b, and 12 c's all together. That is, if I could add, that is 15, right? 2 plus 1 plus 12 is 15. On this one, there are no exponents. We don't see any exponents on variables. So on 76, the degree is going to be 0. All right, identify the terms of the polynomial. That's really easy. There's 4 different terms. So you don't even really have to write anything there, just unless you had already written it above that it's 4 terms. Identify the coefficient. Coefficient is the number in the front. That's not hashtag in front. All right, so the number in the front, so the coefficient on y, if we put a number there, it would just be 1. 3y squared, that's a 3. Negative 5. And here the coefficient is 10, that's just the number itself. Okay, identify the degree. That's just practice with what we did above. And you all, the whole reason they're doing this is because they're wanting you to write it in standard form. So here the degree is 1. Right, secretly there's a little 1 exponent there. 2, 3, and 0. And remember we said we want to write it in decreasing order. So if I'm going to write all of this in decreasing order, I'm going to start with negative 5y to the third because it's got the highest power, plus 3y squared, plus y, plus 10. And the last question is, what is the leading coefficient? That means what is the very first number on the very first term. So the leading coefficient here is going to be negative 5 because it's the very front. All right, that's the vocabulary you need to know for today. And now with our examples, I'm going to kind of scroll past. You may want to label your notes. We're going to add polynomials. I'm just going to do probably one of these examples, and then we'll move on because I don't think you're going to need more than that. You all probably already know how to do this. Just remember to put all of that together. We're going to combine like terms. Since there are parentheses, I guess technically we should be distributing, but here you're only distributing 1, so it's not going to change the signs or the values of anything in those parentheses. I always work from the highest exponent down. So the highest one I see is right here, negative 9x to the 7th. I don't see, and if you want to cross that off so you know you've taken care of it, and then I just count down. I don't see anything to the 6th power. I don't see anything to the 5th. I've got one thing to the 4th. That's my 17x to the 4th from the front here. To the 3rd, I've got 2 things to the 3rd, negative 2 and 11. When I add that together, I'm going to get plus 9, x to the 3rd. Pay attention to the fact that I'm not changing the exponents when I add them. I'm just changing the coefficients. All right, so I took care of those. To the 3rd squared, I've got a negative x squared, positive 8x, and a negative 8x. Those cancel. So I'm not even going to write anything down for x squared. No x's by themselves, and the last thing I've got is a plus 4, plus 12, so plus 16. And there I added, and my final answer is already in standard form. Just to review those terms, there are 4 terms here, 4 separate pieces. The degree of this polynomial is 7, because that's the highest degree on any single term. The leading coefficient is negative 9. All right. Subtracting, that's the next thing we're going to do. So if you want to label this last example subtracting. So down here, this is very similar to what we just did, except this time when we subtract, notice there's parentheses, but really on the second parenthesis, you're distributing a negative 1. So what I like to do is go ahead and just change all the signs. It just makes it easier for me to see. So I'm just going to write this out. 23rd x to the 7th minus 9x to the 4th plus 1 plus 9x to the 4th, right? I'm distributing a negative 1 minus 6x squared plus 31. And now we're just combining like terms. Some of you may also have found before that in the past it helps you to like underline or circle the things that go together just to kind of see that a little bit more quickly. So my final answer here, 23x to the 7th. My x to the 4ths actually cancel. Minus 6x squared plus 32. I can't combine anything else that's left because nothing else has the same exponent. So there is my final answer. That's a polynomial with 3 terms, and it has a degree of 7. Okay. The last thing, this is just modeling with addition and subtraction. Modeling in this book, if you haven't figured out, is just a fancy word for word problems. And these look really complicated when you first read them, but they are not. I promise you, these are going to be the easiest word problems you do all year long. So let's scroll and we can do one together. All right, let's do this one back here. Okay, so I'm going to actually pause and give you a second to read all of this. Okay, so a few things we need to do. First of all, just to kind of make sense, make sure that you understood. A of X, these are the commercially owned automobiles after 1990, where X is the number of years. If you keep reading, P of X down here, this function is for the privately owned automobiles after 1990. So we've got 2 different pieces, commercial and private. And the question that they're asking, if you read carefully, they ask a few different, well, they really are asking you one thing, but we're going to actually write a function. They want us to estimate the total number. And total, if you've got 2 pieces and you want to know the total, you should be thinking that we're going to need to add those 2 things together. So shorthand, I'm just going to say we're going to add A of X plus P of X. And instead of writing all that out, which you are welcome to do, I can kind of look up at the top and just put my pieces together. So I've got my x thirds are going to go together. That's a negative 1. So take a second to match those up, and let's compare what answers we get. All right, that's what I got. So this is the function. What we just wrote down is the function of this general problem. And then they're asking specifically to estimate the total number of automobiles owned in 2005. Now remember, they're starting at 1990. So from 1990 to 2005, that whole span is going to be 15 years. So 15 is the number that we're trying to evaluate. So that's actually what we're going to plug in for all of these x values. And I'm going to be lazy. Don't be like me. Be better in your notes. I don't have a good calculator with me as why, but the idea is you're just going to take 15 and plug it in right there to figure out what would have been the total number of automobiles in that year. Okay, so like I said, super, super easy lesson. I think that you probably already knew all of those things really without me having to go over them. So should have been a quick set of notes. These questions down here are what we're going to talk about to start out the lesson tomorrow. So you may just want to glance at them. Make sure you can answer all of those. If you can't, maybe take a second to go back and rewatch part of the video.